The world needs better ways to store electricity, and with a huge boom in electric vehicles and energy storage systems, companies, and even whole countries, know that whoever makes a reliable, powerful and cheap battery and figures out how to produce it on a big scale will make a tons of money, at least until competitors catch up. That's why there is a big race in battery tech right now. People are working to make existing batteries better and invent totally new ones. So, welcome to my channel. My name is Dima. I'm going to show you 5 super exciting battery technologies that could totally change electric cars, smartphones, energy storage systems, and even airplanes in the next few years. This video is a quick overview, but each technology deserves its own video. So, get comfy and let's get started. So, our first candidate for a battery revolution is, of course, solid-state batteries. What's the idea? Regular lithium-ion batteries use a liquid electrolyte, a special liquid that moves lithium ions between the positive part, cathode, and negative part, anode. What's the problem here? This liquid can catch fire, degrades over time, and limits how strong or small a battery can be. Solid-state batteries fix this by using a solid material like ceramic, plastic or even glass instead of liquid. The ions still move, but through a solid. What's awesome about them? First of all, safety. No liquid means way less chance of fires. No more scary stories about electric cars or phones catching fire. More power. These batteries could store up to 2 times more energy per kilogram than today's lithium-ion batteries. That means longer range for EVs without making the car heavier, or smaller batteries for the same range. Long life. The solid material does not degrade as fast. These batteries could handle thousands of charge-discharge cycles without losing much power. But there is a catch. They are super expensive to make right now. The materials are tricky and mass production isn't ready yet. Also, there are problems with how the solid material connects to batteries' electrodes, especially after long use. Still, big car companies are pouring money into this. They say they will start selling these batteries in 3 to 5 years. In early 2024, Mercedes tested a solid-state battery in an electric EQS, and it gave 30% more range without adding weight. It's not a car you can buy yet, but it shows solid-state batteries are moving from labs to real roads. The question is, who will figure out how to make them cheaply first? So, solid-state batteries are more of a tomorrow thing, but when they are ready, they could make EVs lighter, safer, and cheaper to run. Next one, sodium-ion batteries. Everyone's talking about lithium. Lithium-ion batteries, lithium shortages, crazy prices, but there is a cool alternative that could shake things up: sodium-ion batteries. The idea is to replace expensive rare lithium with sodium. Sodium is everywhere, in seawater, salt, dirt. Unlike lithium, which comes from just few places, you can find sodium all over the world. So, how do they work? They are a lot like lithium-ion batteries. Sodium ions move between the cathode and anode to make electricity, but they use cheaper, easier to make materials. Why they are great? First of all, they are cheap. Sodium-ion batteries could cost up to 40% less than lithium-ion ones, because the materials are so easy to get. They are tough. They work better in cold weather and don't degrade as much during fast charging or discharging. Perfect for cold countries or public transport. They are eco-friendly. As you know, mining lithium is bad for environment and there is not much of it. Sodium has way fewer problems. But what's the downside? They store less energy per kilogram than lithium-ion batteries. That's a problem for phones or fancy EVs where you need small, light batteries. But for cheap EVs, city buses or storing energy from solar panels, price matters more than size. China Kettles, a huge battery company, has already started making sodium-ion batteries. The first EV with them, like JAC YY3 or GM EV3, are hitting the streets for the city driving. Other companies like BYD are also working on more models. So, sodium-ion batteries are real right now. They are a great option for affordable city transport and energy storage, freeing up lithium for high-end gadgets. The next one, silicon anodes. Most EV batteries today use graphite anodes. This is a negative part. But there is a better option coming, silicon anodes. Why silicon? This is simple. Silicon can hold 10 times more lithium ions than graphite. More ions means more energy, so you can get longer range for the same battery weight. Sounds good, right? But it's not so easy. When silicon takes in lithium, it swells up to 3 times its size, like a sponge. Then it shrinks back when discharging. This is constant expanding and shrinking breaks the anode, so the battery wears out fast and loses power. Scientists have been working on this for years. They are trying tiny nano-sized structures, mixing silicon with graphite or using special materials to keep silicon stable. But there is a good news. Some batteries already use a bit of silicon in anodes. For example, certain Tesla Model Y batteries and Panasonic batteries have some silicon to boost power and charging speed. Companies like Sila Nanotechnologies for Group 14 Technologies and Amprius are working on a full silicon anodes that could increase energy up to 40% without losing lifespan. What does it mean? Faster charging batteries, EVs with 700 km range and lighter batteries for drones, phones and laptops. Silicon anodes are not a far-off dream. They are already in some products and will power more EVs with amazing range and fast charging. The next one is lithium-sulfur batteries. Besides solid-state and silicon tech, there is another exciting option, lithium-sulfur batteries. What's the idea? Use sulfur for the cathode instead of expensive heavy materials like cobalt or nickel. Sulfur is super cheap, common and light. Why are they cool? More power, they could store up to 3 times more energy than lithium-ion batteries, letting EVs go up to 1000 kilometers on one charge without extra weight. They are cheap. Sulfur costs almost nothing compared to rare materials, so these batteries could be way more affordable. But what's the problem? Sulfur forms compounds called polysulfides during charging that could leak from the cathode, messing up the battery. This makes it lose power fast, sometimes after just 100 cycles. Engineers are tackling this by making special cathode designs to trap polysulfides, or using protective layers or new electrolytes. But recent test batteries last up to 1000 cycles, which is good enough for real use. Companies like Axis Energy, before it was closed, Lighten and Cyan Power have been testing them. They are also a big deal in space tech, where lightweight and high energy matters, even if the battery does not last forever. If they get it right, lithium-sulfur batteries could change the game for long-range EVs, trucks and even planes. They are not in stores yet, but they are getting close. And the next one, next generation lithium iron phosphate batteries. Lithium iron phosphate batteries are not new. They have been around since early 2000s, used in buses, energy storage and budget EVs. But now, they are making a huge comeback with upgrades. Why are they awesome? First of all, they are safe and reliable. They are way less likely to catch fire or overheat than lithium-ion batteries with cobalt or nickel. Long-lasting. They can handle up to 5000 charge-discharge cycles without losing much power, up to 3 times more than regular lithium-ion batteries. They are cheap. Iron phosphate are common and affordable, so LFP batteries cost less for the same power. But what's the problem? They used to be heavy and bulky, storing less energy per kilogram, which wasn't great for EVs. But now, companies have improved LFP batteries with tiny nanostructured cathodes and better designs. Their energy density is almost as good as older lithium-ion batteries. Plus, they work better in cold weather, which used to be a big issue. Tesla uses LFP in its base Model 3 and Model Y for China, and BYD's blade batteries, a new kind of LFP, are super tough and have great energy density. These batteries will power affordable EVs, making them reliable, long-lasting, safe, and compact enough for everyday cars. So, that was my quick look at the 5 coolest battery technologies. There are lots more out there, and each could get its own video. Comment below which any awesome battery tech you know about, and we'll see you in the next one. Bye bye.